In this lab, we tested Newton's second law of motion. We put an object in motion and tracked its velocity in one direction. We found that since there is no force acting on it, there was no acceleration. Therefore, the final velocity was equal to the initial velocity, and Newton's second law was upheld. This is the video I used as evidence for my conclusion. I will show you how I use this video later, but you can tell from the video that there is no force acting on it other than the friction from the surface. I used Tracker to track the motion of the object. This gave me my actual data that I could use to compare to my theoretical data. I used the first and last points to calculate the average velocity, which I then used to find the theoretical velocity over time. I then used the starting point, average velocity, and time elapsed, which I got from Tracker, to put into my VPython code. When I run this code, it gives me my predicted velocity over time. There is no force in my code, so the velocity is constant. I extracted the data from both Tracker and VPython and put in a Google spreadsheet. I graphed the data, and this was the result. As you can see, the two lines, which represent the observed and the predicted velocities, are very similar. Or Newton's second law, which states that final velocity is equal to initial velocity plus force multiplied by time and divided by mass, is upheld. If we flip the axes, the conclusion would be the same. However, it would show movement in the negative x direction. This would not change the overall result. My results show that there is no net force acting on this object. However, there are multiple forces acting on it. There is gravity, pushing the ball against the table, the normal force, which is opposing gravity and pushing the ball up, the initial force from the push of the hammer, and the opposing forces of that, which are drag and friction, which are practically negligible in such a short time window. Therefore, the net force is practically zero, which keeps the velocity constant.